our problem was x over x squared plus 9. So make sure you are paying attention throughout this. It's up to you. These are your examples for the section, so up to you if you need to write them down. But you will have them on your homework.
It's just say
A is the domain.
Okay, so to figure out A, we did x squared plus 9. We set it equal to 0.
Because domain is asking you what x can be. You know, if it's a polynomial, we know x can be anything. If it's a fraction, we know the bottom can't be 0.
So if you do that, you get an imaginary number, so you just figure out that it never equals 0, so you're just going to get negative infinity or positive infinity.
So x and y intercepts.
Mm-hmm.
So x-intercept, you're going to set y equals 0, so multiply that off the bottom, and then x is just going to equal 0. And then y-intercept, you're going to set your x is 0, so then this just equals 0.
I'm going to just label a couple things here. So we had our domain, x-intercept and y-intercept that we found so far. All right, good. Next step.
Okay, so then we found our vertical asymptote for C, and because it was negative infinity to positive infinity, we know that our bottom's never going to equal 0, so then there's none.
Everyone understand that? So your domain and your x-intercept, or your domain and your vertical asymptote are very closely related. They're both just looking at when the bottom's 0.
And then your horizontal asymptote is the limit as it's approaching positive and negative. Is that how you do it?
Yeah, that's how I did it.
So then I multiplied by 1 over the highest power of x, so 1 over x squared. Then I got 1 over x over 10, is that right?
No, it's plus 9 over x squared.
1 plus, because x squared over x squared would turn into 1.
Yeah. 1 plus 1 over x squared.
9 over x.
9. And then you do some math and you get that y equals 0.
So it's x increasing and decreasing in critical points, right?
Yeah.
So with the derivative,
So we're doing the quotient rule.
And then that comes out to be. And then you set it equal to 0 to get your critical points. So then x equals positive negative 3. And then,
Remember, you're always, when you're checking those signs, you're putting them back into the first derivative to check positive and negative.
so there's increasing and decreasing and then critical points.
Okay.
So then for your local max and local min. It's positive there, so your local max is going to be at 3. And then your min's going to be negative 3, and then you plug that back into your original equation, and you'll get that your local max is 3, 1/6, and your local min is negative 3, negative 1/6.
Good.
Then inflection points. Gonna get your second derivative.
So we're doing quotient rule again, low D high minus high D low. You have to do chain rule within that.
So then that cancels out. And that does. So then
To reduce the x squared plus 9 over everything, it's just multiplying out what's left.
from there it should be. So that's your second derivative, and then you set it equal to 0. Get rid of the bottom, so then it's and then you set that the x is equal to 0, and you get 0 and positive and negative 3 radical 3. You're gonna do that. Okay.
You can write it down, but then you're gonna make your graph. And then if you plug all that back into your derivative, it's gonna be negative, negative, positive, positive.
I think it should be negative, positive, negative, positive.
So probably just plug it in.
Yeah,
Yeah.
so, okay. I might take over and finish since we're running short on time. Sorry about that. So I'd say you probably just had an error plugging it in. So we're putting it in right here. You might have forgotten your denominator or something. So when we do that, we see it's concave down from negative infinity to negative 3 radical 3, and from 0 to 3 radical 3, and concave up from negative 3 radical 3 to 0, and 3 radical 3 to infinity. We will graph this one together at the beginning of class tomorrow.